Welcome back everyone to my channel Chemistry Made Simple for NEET. I am Dr. Radha Subramaniam with a PhD in Chemistry. So today we are going to continue with the second part of the unit General Principles and Process of Isolation of Metals part 2. I have already uploaded part 1 of this particular unit and this is one important unit where you are likely to get many questions for the NEET exam. Okay, so before we continue with the important concepts for today, I'd like to share some important tips given by experts for attempting the exam. So first of all, it constitutes the elimination of options. So all that you need to do is realize that out of 4 probable answers, around 50% are not accurate. So if the option seems too close, be quick to reverse check them if the options satisfy the question. Do remember that these tricks work on a few numerical only. Then filling OMR sheets, taking the right answer is easy, but for now it's important to figure out a trick for filling the OMR sheet quickly and effectively. Imagine missing out on a question and filling all the options at once, and also you have to try watching some videos available on YouTube over how to quickly fill OMR sheets. Okay, now mnemonic phrases are useful, but students find it difficult because there's already a vast amount of syllabus to learn. If students can find out some catchy mnemonic phrases and accordingly relate the words with topic. Always a lot of times questions come up with random information that does not relate to the question at all. To solve 180 questions in 3 hours, students must learn to avoid such information and quickly read the questions. This will in turn increase their speed. It is easier to read and learn information from a table. The major highlights, characteristics, uses, etc. of any particular element can be put in a table. This will help in quick reading while revisions. Okay, with that we will move on to the next concept of this lesson. So we were talking in our last session about various methods of concentration of ores, and we learned about roasting, then calcination. Okay, we learned about the blast furnace and all those things. Those who haven't watched that unit can go to that video and watch. Okay, now we'll learn about the metallurgy of aluminium. So here in the metallurgy of aluminium, purified Al2O3 aluminium oxide is mixed with Na3AlF6 or calcium fluoride. That is, what is the purpose of that? It lowers the melting point of the mix and brings conductivity. So the fuse metric is first electrolyzed and you use steel cathode and graphite anode. Importantly, remember that graphite anode is useful here for reduction to the metal. So the reaction can be written like this: Al2O3 plus C will give Al plus 3CO2. This process is very important. It is widely known as Hall-Héroult process. So remember this process. Next topic, that is here we can see the diagrammatic representation for electrolytic cell for the extraction of aluminium. See, we use carbon anode. You can see carbon anode, then we have got a copper clamp and anode over here, then negative cathode. Carbon lining acts as the cathode. This is the outlet for aluminium. Here we are taking molten aluminium plus Na3AlF6 as you saw before, and this is iron. Okay, now what is refining? See, once the metal is extracted by any method, usually it is contaminated with some impurity. So to obtain metals of high purity, we use several techniques depending upon the differences in properties of the metal and the impurities. So many the important methods are distillation, liquefaction, electrolysis, zone refining, chromatographic methods. Last year for NEET 2021 we had some questions based on this, so you have to revise all these concepts thoroughly. Now what is distillation? See, it is used for low boiling points like zinc and mercury. The impure metal is evaporated to obtain the pure metal as distillate. So they will be asking for NEET, a method for low boiling metal. Now what method do you use? So for zinc and all that. So you have to remember it is distillation. Okay, now next question, liquefaction. So here in this method, a low melting metal like tin can be made to flow on a sloping surface. So it is separated from higher melting impurities. Electrolytic refining by electrolysis. Impure metal is acting as an anode. Strip of the same pure metal is used as a cathode. So you put that in a electrolytic vessel. It contains soluble salt of the same metal, and more basic metals remains in the solution and less basic ones will go to the anode. So this process is explained using the concept of electrode potential, then over potential and Gibbs energy. Reaction taking place at the anode and cathode are given here. Metal, you can see here the reactions. Just run the reactions of the anode and cathode by writing these out. Okay, now next one. For copper, what is the electrolytic refining process? Copper also is refined using electrolytic method. What are the anodes? Impure copper, and pure strips are taken as a cathode. Electrolyte is acidified solution of copper sulfate, and the electrolysis result is a transfer of copper in pure form from the anode to the cathode. You can see here anode, what reaction? Copper Cu2 plus plus 2 electron, and cathode Cu2 plus accepting 2 electrons and getting copper metal. So impurities from blister copper will deposit as anode, which contains antimony, selenium, tellurium, silver, gold, platinum, and recovery of the elements may meet the cost of the refining. So remember that point. Then next, zone refining. This is very important method based on the principle that impurities are more soluble. Remember, impurities are more soluble in the metal than in the solid state of the metal. They are more soluble in the melting stage of the metal. So a circular mobile heater is fixed at one end of the rod of the impure metal. So what happens is that the molten zone will move along with the heater when the heater is moved forward. So the heater is moving forward, like this. Pure metal will crystallize out of the melt and impurities will pass on to the adjacent molten zone. This process is repeated many times. The heater is moved in the same direction, and one end the impurities will get concentrated, and you can cut it off from that time. So very useful for producing semiconductor and other metals of high purity like germanium, silicon, boron, gallium and indium. Next, chromatographic methods. So here, what is the principle of chromatography? Different components of a mixture are differently adsorbed. Already I have taught you about adsorbent and all that in surface chemistry. So the mixture is put in liquid or gaseous medium which is moved through the adsorbent, and different components are adsorbed at different levels. So after that you can remove the adsorbed component by using suitable solvents. So depending upon the physical state of the moving medium and adsorbent material, and on the process of the passage of moving medium, chromatographic method is given the name. And what are the chromatographic methods? So it contains a solution of a component which is in the liquid form, and column chromatography useful for purification of elements which are available in very small quantities, and impurities are not very different in chemical properties from the element to be purified. So several techniques are there like paper chromatography, column chromatography, gas chromatography, etc. So here industrial method and laboratory method. You see in industrial method, these are the parts: flow meter, detector is there, this is the column inside the oven, flow injector, pump is there, and the solvent tank finally. In the lab we use this, mixture of compounds and stationary phase. Okay, then colored bands are here. Okay, what are the uses of aluminum? Aluminum foils, you should have seen that as wrappers for chocolates. Then the fine dust of the metal is used in paints and lacquers. Aluminum, it's highly reactive, used in the extraction of chromium and manganese from the oxides. Aluminum wires, we use it for as electric conductors. The alloys containing aluminum, very light, they are being very useful. Then uses of copper, it's used to make wires in electrical industry for water and steam pipes. Used in several alloys which are very tough than the metal itself, like brass with zinc, bronze with tin, and coinage alloy with nickel. And what are the uses of zinc? Zinc is used for galvanizing iron, used in large quantities in batteries as a constituent of many alloys like brass, copper 60%, zinc 40%, German silver, copper 25 to 30%, zinc 25 to 30, nickel 40 to 50. Zinc dust is used as reducing agent in the manufacture of dye steps, paints, etc. Then uses of iron. Cast iron is the most important form of iron, used for casting stoves, railway sleepers, gutter pipes, toys, etc. Used in the manufacture of wrought iron and steel. Wrought iron is used in making anchors, wires, bolts, chain, agricultural implements. Then steel finds a number of uses. Alloy steel is obtained when other metals are added to it. Nickel steel used for making cables, automobiles, aeroplane parts, pendulum, measuring tapes. Chrome steel for cutting tools, crushing machines, and stainless steel for cycles, automobiles, utensils, pens, etc. Don't think that I am moving so fast with this these type of concepts, because it's all very easy, and if you delay these topics too much, then we won't get time to move through the tougher topics. With that, we have got some lessons left out from organic chemistry, then physical chemistry lessons are there, so I just want to upload it fast, but this is an important lesson, so I thought it would be useful for all of you. So if I upload this first. Okay, now coming on to the end of the chapter. So I hope you understood these concepts very well. I've tried to include all the important concepts from the textbook NCERT here. Even state students, syllabus students can find this and learn very easily. So as usual, do surely share this video with your friends, and please do like, share and subscribe to my channel and press the bell icon so that as soon as I post new videos you will get a new identifications and notifications immediately. So I'll be coming quickly with the remaining lessons and the most important MCQs of different units. And thanks for watching my video.